So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is lecture number 14 of the linked list series, right? So what does the question say? The question today is palindrome linked list. Palindrome linked list. The question says that you have been provided with a linked list. Suppose your linked list that is given to you as input is 1, 2, 2, 1. You will have to tell me whether this linked list is a palindrome or not. Whether this linked list is a palindrome or not. So let us define the word palindrome first. So palindrome actually stands for that if you read it out from left to right, from left to right, will it be same? Will it be same for reading right to left? For reading right to left. Right to left, right? That is, if I read it right to left to right, so left to right is 1 2 2 1, and what is right to left? Right to left is also 1 2 2 1. If these two pronunciations are equal, then that is known as palindrome. Right? So one example is 1 2 2 1. Another one can be 1 connected to 2 connected to 1. You can see 1 to 1 is this side and 1 to 1 is this side, so both of them are equal, so it is also a palindrome. But a sequence such as 1 2 3 1, it is not a palindrome. You can see if I read it this direction, it will be 1 2 3 1, but in the case of the different direction, that is opposite direction, it will be 1 3 2 1, and it is not a palindrome. The problem behind you is that you have been provided with a linked list, and you have to tell me whether this linked list is a palindrome or not. Is this linked list is a palindrome or not, right? You have to return the bool value. Now how will you solve it? So the basic approach that everyone can think of right now is that if the given linked list is 1 2 2 1, what do I have to do? I actually have to compare this linked list with its reverse, right? With its reverse. That is the whole concept, with its reverse, right? So what I will do is I will create another linked list of same type, but I will make it in reverse order. That is, this is my linked list 1, and my reverse will look something like 1 connected to 2 connected to 2 connected to 1. Now what I will do, I will keep a pointer here, let us say A, and keep a pointer here B, and start traversing. If A equals to B, move ahead. A comes here, B comes here. A equals to B, move ahead. A comes here, B comes here. A equals to B, move ahead. A equals to here, B equals to here. A equals to B, move ahead. A equals here, B equals. Up until then, if A and B are both null, then return true. Otherwise, if any of the cases A's value is not equals to B's value, that means the given linked list is not a palindrome. That is the base condition, right? This is the condition, right? Now one approach is this. So what is the time complexity here? So you are actually seeing that you are actually reversing. So for reversing, you have to first copy the linked list, right? That is why, that is only how you can get another linked list, right? After that, reverse the linked list, right? And third option is traverse the linked list. So you actually use O of n time complexity here, O of n time complexity here, O of n time complexity here, and the space of complexity, because O of n is here because of the copiness, right? I am creating new nodes. So O of n is the space complexity, and O of 3n is the time complexity. O of 3n is the time complexity, and O of n is the space complexity, right? So O of n it is, right? In this case, O of n. Can I optimize it? I already have a question that is good enough for me, but I want to optimize it. How can I do that? So let us try to eliminate this first. If I try to remove the space complexity, what I can do? Suppose I have the given linked list as 1 2 3 2 1. First of all, tell me, is it a palindrome? Yes, because 1 2 3 4 1, 1 2 3 2 1, and 1 2 3 2 1, both in the same direction are equal, right? So how will I solve it without using any extra space? My goal now, right now, is to not use any extra space. That is, I don't want to copy it, right? Not use any extra space, right? So my first step says that, see, this element is actually getting compared with this element. This element is actually getting compared with this element, and this element is actually getting compared with this element only, right? So If I mark them indexes, so 0 index, 1 index, 2 index, 3 index, 4 index. What is the length of the linked list? Length is equals to 5. You can see 1, 2, 3, 4, 5, right? And I can see 0 is getting compared with 4, 1 is getting compared with 3, 2 is getting compared with 2. Now, as we solved in the question of patterns also, are you able to observe a pattern? Yes, I am able to observe a pattern. 0 plus 4, 4. 1 plus 3, 4. 2 plus 2, 4. And what is 4? Length minus 1. I can say length minus 1. So I got my algorithm. What will I do? I will first calculate my length. Second step, I will keep my temp here. I will keep my temp here. Up until which value will temp go? See, this is a case of odd. So you are able to see that temp is actually going to 2, that is 5 by 2, right? But in the case of even, what will happen? So 1, 2, 2, 1, 0, 1, 2, 3. You are able to see that 0, 1, temp is only going up till 2, temp is only going up till 2. So it is 4 is the length, so 4 by 2. No, 4 minus 1 by 2, that is working. So I will say 5 minus 1 by 2. So my temp will go up till length minus 1 by 2 for comparison, right? Now, wherever my temp is, third position is, suppose my position of temp is I. My position of temp is I. I will have to use another pointer. Suppose I keep my temp here. I keep my temp here. Now what I will do, I will keep another pointer here and start traversing. Up until when I will have to traverse? I want to compare this 2 with this 2, right? So I will have to traverse A up till here, right? For that I will need the position, that how many jumps I need to make. How many jumps I need to make. So you can see from here that temp is at position equals to I. Temp is at position equals to I. Position of the second pointer is, position of A would be length minus 1 minus I, right? From these operations, length minus 1 minus I. Position of A is found out. Now position of A is length minus 1 minus I, right? So for reaching 3 positions, you have to see that 1 jump, second jump, third jump. I have to take equal number of jumps. So I will say, I will take traverse A length minus I minus 1 number of times, right? And after that, if I will use a condition, if temp's value is not equals to A value, that means it is not a palindrome. In that case, return false. Otherwise, temp will move to next. Otherwise, temp will move to temp equals to temp next. And also don't forget to increase its position. Temp equals to temp next and position plus plus, right? So I hope that was clear to you. But what is the time complexity now? So you see, we are actually carrying out the length. So O of n is getting consumed there. Now I am saying that it is getting up till length minus 2. So O of n by 2 precisely, right? Position equals to I. This is actually working O of n number of times in a nested loop. If you see, the loop is actually working like this is the temp loop, right? And for each temp, my A's loop is coming, right? My A loop is coming. It is a nested loop, so it is actually coming n times. So it is in the nested sentence. So it is somewhat of n square. The current algorithm is working in n square. The current algorithm is working in n square, and that is not a good approach, because we have already devised an approach which is running in O of n, right? But our main motive was to not use any extra space, right? You can see that we have not used any extra space. It is running in O of 1, but we need to deal with this. My basic handling is that I want an approach that runs in linear time and uses constant space. I want to conquer that approach. Is it possible? Let us see. So suppose, given linked list is, let us take the same example, 1, 2, 3, 2, 1. This is my linked list, right? We already conquered that this is getting compared with this is getting compared with this, and this is getting compared with this, right? And when do I stop? I stop at the mid. This is my mid element, right? This is my mid element. I stop here. What I'm saying is that reverse this portion. The basic limitation of the linked list is that I can only traverse in left to right direction. If I was able to travel in the right to left direction, there would not have been problem. Why? Because I would have kept a tail node here, and I could have easily gone here, 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 and temp would have gone here, 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 and I would have compared, right? But that is not the case because it is a single linked list. So what I will do, I will say reverse this portion, that is mid till last. The linked list will now look like 1, 2, 1, 2, 3. Suppose I have reversed it, so it will now look like 1, 2, 1, 2, 3. This portion is reversed. Now what I will do, I will keep a pointer at mid. I will keep a pointer at mid, let us say it B, and keep a pointer at A, right? Now what I will do, I will name it as mid. I will name it as mid. My approach will be compare A data with B data. B data. As you can see, this was getting compared with this only, and this is getting compared with this only right now also, right? I will give a mid. Till then, I will say if A equals to B, move A. That is, A comes here, B comes here. Compare. 2 equals to 2, again. A was here, B was here. Now A will come here, B will come here. But as soon as your A and mid gets coincided, drop the loop. As soon as your A and B gets coincided, drop the loop, because you have actually established that this is a palindrome. This is a palindrome. Let us see once again what I have done is, I have said the given linked list to me is 1, 2, 3, 2, 1. This is for odd case, right? This is for odd number of case. We will be seeing for the even case also. What I am saying is, first option is find mid. Find mid. This is my mid position, guys. This is my mid position. If you don't know how to find mid in O of n time, don't worry. I have already made the video and attached a link to the description. So please don't worry and have a look at it, right? So find mid. You have the position of the mid. Moving on, second approach. What will I do? I will say reverse mid till tail, inclusive. Mid till tail. The current linked list becomes 1, 2, 1, 2, 3, right? After reversal, right? After reversal. Now what will I do? I will say A equals to head, right? B equals to mid. A equals to head, B equals to mid, right? You can even break this connection. You don't want this connection also. You can even break this connection. You keep B here, you keep A here, and now compare. Now, fourth option, while my A is not equals to null and my B is not equals to null, just for the safety purposes, B is also not equals to null. What will happen? What will happen? If my A data is equals to B data, that is, there is no problem because the comparison is going fine. So what do? A equals to A next and B equals to B next. As you can see, 1 is getting compared with 1, so A will come here, B will come here, right? If suppose it was 3 here and it was 2 here, now it should give a wrong answer, right? It should give a wrong answer. So what we'll do? In the else case, you say if A's data is not equals to B data, return false. Return false. Because the comparisons which have to be done are not getting fully fulfilled. Because I am saying that 1, 3, 3, 2, 1. That is not a palindrome, right? 1, 3, 3, 2, 1 is not a palindrome, right? But let us say if that is not the case, if 3 is not the case, right? What will happen then? My A was here, again 2 equal to 2, so A will go to null. This is my null here. B will go to 3. But as soon as A gets to null, I know that this is a linked list of odd length. That is why A got to null, but B is still there. But in the case of palindrome of odd length, I only have to compare the two values here, right? N minus 1 by 2 values. And I can see that that is running fine, and I can simply return true. If this while loop runs without any returning false, I can say after this while loop, return true. Return true. Just we saw the example of the odd case, but just to confirm, just to get the clarification, let us see for the even case also. So 1 here, 2 here, 2 here, 1 here. We discussed in the get mid video, which is already posted. I have provided the link in the description, that I will be finding second mid, right? This is my mid. Again, shifted. So 1, 2. This is my one of the linked list, and another linked list after reversal becomes 1, 2. Again, keep a here, keep a B here. A equals to B, yes. A equals to B, yes. A comes here, B comes here. As soon as they come null, I can simply return true. I can simply return true. Now, if you are able to see that I am actually using only mid operation for O of n, right? I found mid in O of n time. I reversed the mid plus 1 to tail part in O of n by 2 time. And now I use another traversal of O of n that is this traverse O of n by 2, actually O of n by 2, to see if it is linked list. But the main thing is I didn't use any extra space, so it is space optimized with the complexity of O of 2n, which is actually O of n. So that is the optimum approach, right? O of n time complexity, O of 1 space complexity, right? I hope you understood that. Now it is time for you to please look at the code. So here is the coding section. Before starting to code, I would like to request you to, if you are learning something from this playlist, do not forget to subscribe to my channel and hit the like button. Okay. So I have already copy pasted the code for reversing list and middle node, which I already discussed in the playlist, and the links are in the description. I cannot stress this enough, right? So let us move. So what I am doing is I first have to find the, I will first declare the base case. What is the base case? That if my head is null, simply return true, because in the case of head is equals to null, it is a palindrome, right? That is a predefined case. Now working on list node star mid. What is my mid? I will use the middle node function to find the mid, right? This will give me the mid. Now I will say list node star a equals to head for traversal, and star b equals to mid next, right? And now break the connection between the linked list for a and linked list for b, make it as null. Now b will be storing the reverse list, of the b itself, right? Now what will I do? I will say while my a is not null and my b is not null, if at any point a's value is not equals to b's value, in that case return false. Otherwise a will move towards the next node, that is a equals to a next and b equals to b next. At last, if the while loops run perfectly fine without returning false, that means you have a palindrome in your hand and return true. Let us try to compile and run it. Hope it should work fine. It should not give any error, I guess. It is running fine. Let us try to submit it as well. And it is getting run perfectly fine. So thank you for watching, and we'll meet again in the new video, in the new lecture. So stay tuned and do not forget to subscribe. Thank you. Have a nice day.